All right, so it's that time of year again, 1st of December, where we get to do some admin of code. So this year I've chosen to do it in Ocaml, and the reason for that I posted on my blog, but it's mostly so I can concentrate on functional languages a little bit more. So I used a ton of imperative language, OOP languages at work, and I don't really have that much experience with functional languages, but I quite enjoy functional paradigms. So the style of writing code, it's also very, very different. So, it would be good to learn a new one. And yeah, what's more perfect than the admin of code to learn it? So let's take a look. Okay, historian hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone's heard of him, he was visiting locations that are so significant to the North Pole. A group of senior historians have asked you to accompany them to check places. Someone's gone missing. Okay, you haven't even left yet, and the group of elvish senior historians has already hit a problem. Their list of locations to check is currently empty. So they're just gonna look for him. That's the theme of this year. Eventually, someone decides that the best place to check, best place to check first is the chief historian's office. Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into two groups, each searching the office to trying to create their own complete list of location IDs. Okay, there's just one problem. By holding up the two lists side by side, it quickly becomes clear that lists aren't very similar. Could you help them reconcile their lists? Okay. Maybe the lists are off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list, and then the second smallest. Okay, so we're sorting both. Within each pair, figure out how far apart the two numbers are. You'll need to add up those distances. So 3 and 7, that's 4. 9 and 3 is 6. So it's the absolute distance. There's no negatives involved. Okay. Cool. I've already got a file with this in. So let's just okay. So we can do a scanf to to take in a string and read it. So I need to read file. Ocaml read file line by line, which I've already had a look at. Let's have a look. If you want the batches to include library, you could write this looks fine, I guess, but not too nice. Why is this? There's so many weird ways to do this. So we can do in channel.read lines file to read. And then list.iterate through handle line. Right. So in channels. What lines are in channels dot file read? What was that? Read dot. Oh, okay. Hold on. Open core dot standard. Is that how I have to do it? How do I do it? How do I do this? Okay, maybe I do just use this little imperative approach for a sec. Read lines. Okay, so read line file name. Wait, why is there an Alexa talk? Echo. Alexa. What the hell? Sure. What is all this, bro? This seems way too weird. This is not okay. Like this can't be that hard. Reading files in Ocaml. This is a good start. This is such a good start. Why do I have to do like these weird? Oh, okay. Wasn't as straightforward as many other programming languages. Yeah, sure. To give some point of reference, this is how you do it in Ruby. Oh wow. Okay. Wait, okay. So let read lines with a name. There's a string. I don't even think we need type annotation there. In incoming, open in name. In let's try read. Try some input line with and line going to none. In and then we recursively match on this. Close the channel. We reverse the list. We return the accumulated value. We call loop with an empty string. And that's the return. Okay, that looks more like what I thought would happen here. Do I even need this though? I don't. Yeah, I don't think I did. Because now I can just yeah, it's a string to string list. So I can do what I can do is I want to read it and then maybe I could print it. Let's print list L, which we make it recursive, right? So we go, actually, no, we don't expose the recursive. It seems to be a pattern I've seen a few times now, right? Where you have the recursive function inside. Let's recursive loop with the accumulated list, which is equal to match the list with, oh, my formatting is all off as well. Ouch. So if it's an empty list, we just print nothing. We do nothing. What would I do here? Nothing. Maybe I can just go with maybe I can go so head, tail, print. This one in line, the head, and then I can go loop tail. Is that not it? So if I go this, I can just, I don't know what to do. Maybe I don't want to do anything. Maybe print in line. I can do loop L. I mean, yeah, we could probably just like do this to be fair, and just move this upwards, move that, and just go print list. How's that? I don't really like. Don't really want to do that much, to be honest. What is this syntax near in? What if I go read underscore lines of dot slash bin slash input.text, I think. And I go and pipe it into print underscore list. What's going on? What is this? Syntax error line 17. Fire over to you. What is this, bro? What is going on? So this should definitely work, I think. What if I get rid of this? Is you the problem? No. What is the problem here? This typed hole should be replaced with an expression of type unit. Is it this? Oh, there's no, I think that was it. Yeah, there's no need for this here. Ah, there we go. Yeah, no need for that there. We're printing. Alright, we're doing good. But what I could do is instead is I could go and give myself two lists, right? So per line, I want to map let handle line equals no. Okay, hold on. Let's do this here. So we have lines in, and then we go maybe processed lines, you know. I need something to, I need a map. Ocaml map. Just no. I want not this type of map. Map function. That's the one. Oh no, we're there. Okay. Okay, well we could write a handle lines and takes in a line and goes, and this is just scanf, which we need to open again, of line that takes in a string, and it goes, what is it, 1 2 3 spaces, so that handle line returns a string. Returns int, ints, and a. Oh. I'm not sure what that does, to be honest. What is going on here? I'm curious if I go and say, okay, we'll do that, and then let's just pipe that into print list. Expressions type, string list, print expression of print, yeah, string list. Wait, we just did this though. Oh, I needed to save? Okay. I can go let num1, num2 equals handle line, and maybe if I do this or something, you know. Maybe I'll do an in there. Oh, sorry. This expression has type int, returning a of type b, and scanf, no? Ocaml. As a scan f. And then it takes in a function as to what to do with them, maybe. Oh, sorry, that's not it. And then a function that takes in num1, num2. I think these might have to be tuples, and maybe print underscore n line, print int num1. This can't, is this wrong? Oh, surround it in brackets, yeah, okay. Print int, takes in this expression, this type unit. If I, no bro, print int just doesn't do anything. So x is an int. X, where it goes. If I do x returns x and I go x equals. Is this not correct then? And do I need to do anything else? Hold on, let's move this down here, just for some, I guess, some little simplicity. And oh no, that's definitely worse. So let fs equals this. The handle line of a new string. I'm so confused. Hold on, let's see. So this guy has f isn't a function, it is a type unit. So when you call print hello, it first unconditionally evaluates print f, which in this case then binds the unit result to f. Okay, not very familiar with scanf. Indeed, I actually wanted the percent. Reading the scan, so the complete version is print hello I. So we scan hello value. Oh, and he's doing the interpreter. Is a string that returns a unit equal to function. Okay. Maybe we are trying to be too clever. No. We scan string A, B, C, D, scanner. What are these? I'm still so confused. Ocaml, let's have a look. Ocaml. Okay. None of this. We just split string. Let's have a look. Not even. Yeah. Okay. Okay. So if we do. Surely I do remember doing something like this. So there is. Hello. Let's see what you have in here. Oh, we have S. This is exactly what I wanted. Oh, okay. There we are. So this is much more like it. Yeah, because I remember doing some practice, so it can't be that stupid. So let's do handle line. And what I had was a scan off that takes in a line, and it does, in our case, 2, 3. This is much less interesting. So it takes in these functions here, num1, num2, and what I do want to return is, I see, I just want to return num1, num2. And our handle line is, here we are, okay, good. And I can now actually do what I wanted to do. And in print int num1, print, I think I go in print int num2. There we are, I think. Is that what we're doing? Without u. Print a square line, test, and then, oh, this isn't actually print an inch in decimal standard format. Print square line, int to string of int num1. Okay, good. So we have a function that handles the lines, and for each of those we want to accumulate 2 lists. Oops. Yeah, so we want to go let build lists that takes in lines. And we do this. For each one. Oh, okay. So let's do let rec loop that takes in a line, and what it does is it does match. No, it does. For each line. No, lines, we have to go do this, handle the line. We have to, hold on. Okay, I'm getting the hang of it, slowly, very, very slowly. This L1, L2, return L1, L2. Heads, tail, we go and we return, we want to accumulate into L1, L2. We're going to call it with, we're going to do loop with line, with the tail, and then we're going to go and say, how do I concatenate? Ocaml add item to end of list. In the list, is this the okay, so we do this here. Tail, so this is going to be L1, ANDed with the oh, we need to first of all do let num1 num2 equals the handle line for the heads, and then we go in loop the tail L1 appended with num1, and then L2 appended with num2, and we go loop that takes in a string of list, returns an oh, what is this? Oh, an int list. An int list returns an int list. Ah, there we go. That's so good. Let's go. So, and then we could just do loop lines empty list, and this needs a one of those, I think. Or not, maybe not. This function loop has string. It is applied to too many arguments. Is it? But this is pretty passive. What we're doing here is not too bad. Hold on. Unused variable. Hold on, what's going on here? This type hole should be replaced with expression type. Oh, I never. This is weird. I don't really know. Oh, do I have to go like in and then do loop lines empty string? I see. I don't really know why I have to do that. I need to read it up on that. But now build list does do the thing I wanted to do. And to be fair, we could then map it to be a function that takes in L1, L2, and returns Ocaml sort list. List.sort. Sort. Compare, so function ij returns whether I is smaller than j. Actually, let's do let sort int sort list. Just gonna go L. This is equal to list.sort that takes in a function, has I and j as arguments, returns whether I is smaller than j. Yep, something like this. Do I need? Special type A list is expected. There, yeah, okay. Special should not be functions. Type A list. What is going on here? Sorting list in Ocaml. I just want list.sort, bro. Just give me list.sort base to have a compare. Oh, go away. Sorry. Instead of integers. Sorting things. Oh, this is not what I want. This is like the aggressive way of doing it, right? Compare. Oh wait, hold on. There was someone over here. What was the compare thing about? No, that's actually wrong. Ocaml sort list of integers. Sorting list. Compare. Oh, do I just do compare and this expression instead? No, sort list. Is there an example? No. Oh, you come first. Okay, and now, okay, good. Sort underscore list of L1, and then sort underscore list of L2. Wait, no, hold on. What is this? Do you now know what you are? L1, L2. Oh, let's go. Let's go. I think we're there. We're nearly there at least. We can go, let's L1, L2 equals build lists with let lines equals this in here. Build list of lines in print underscore list L1, and also print underscore list L2. I could do print in line of string of int, and so, and now print list is kind of specific to, and print underscore list of L2. They are nice and sorted. Good. Now what I have to do is I have to do an accumulate. Yeah, let's recursive of distance. That's going to take in two lists. L1, L2 accumulate equals. Okay, so we're going to match. Yeah, we're going to match L1, L2 with empty, and it goes. Oh my god, we've spent so long. I know, it's actually really fun though. I'm having a lot of fun. H1, T1, H2, T2. So what we're going to do is we're going to go, we're going to do distance of T1, T2, and then the accumulate is going to be accumulate plus if H1 is bigger than H2, then H1 minus H2, else H2 minus H1 in, oh no, did not like that. This pattern match is not exhaustive. Is there, can I just do this underscore and then do like raise unreach? Wait, okay, hold on. Ocaml ignore exhaust. Can't spell. Pattern matching. Suppress exhaustive. You can do. Oh my god, that is big. That is really not. Can I do an underscore of sorts? Type annotate the struct line in numeric case, use existing match. Yeah, would this do okay? Just return ACC. This is never gonna happen. This match case is unused. What? Why? Oh, because this is the thing. Yes, that's the one. In, no, not you. You don't go there. In that's it. So this is an int list, like returns int and int. Wait, returns. Oh, that takes in an int, returns an int. I think now what we can do is just say int let part1 equals distance of L1, L2, 0 in print underscore end line part1 yeah, like, wait, hold on, printf dot printf part1 string of int part1 not you, and this. $11 for the example. God, that took us a while. But it did work. So let's take a look. There we are. There we are. Good, that only took way too long. But having so much fun. Actually having so much fun with Ocaml right now. This is so sick. It's just such a different way of thinking, and the syntax is different. It's very exciting. Okay. Part 2. Your analysis only confirms that everyone feared. The two lists of location ID are indeed very different. Or are they? The historians can't agree on which group made the mistake or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Okay. The first number in the left list is 3. It appears in the right list 3 times, so the similarity score increases by 9. The second number in the left list is 4. It appears in the right list once. Ooh. Right. That's kind of yeah, interesting. There's two things coming to my mind. So you could just do a set of, yeah, I think you would build a set for the numbers and how many times they appear, but I kind of want to do it as if only functions exist, like no complex data structures. What I want to do is I want to go through each one on the list on the left, and then do like some tail recursion to count. So instead of doing it before, we're doing it during, which could be super inefficient, probably is, but I think it would be a more fun way to write this. So that's what I'm going to do. So we're going to do probably just continue doing it in line here. We're going to do similarity, that's what they call it, similarity, yeah. Takes in L1, L2, accumulation. So we're going to do a very similar thing to the top with, we're going to do another function called let recursive find instances. Oh, what's the word? Find occurrences. Find occurrences in L in list, and then item and we're going to do something kind of similar here. L item, and then the accumulation, which is we're going to match on L. If it's empty, we just return the accumulation. Otherwise, we do head tail recursion, and head tail recursion of, we go if head is equal to item, then we do loop on the list, the tail, sorry, the item, and then the accumulate +1, else we don't do that. And then we go loop with L, the item, 0. What is this? Supply to any items, loop, tail, item, accumulation. Do I need that? No, I just need this. And then fire occurrences is takes in a list and item returns int. Yeah. Okay, so our match here, we do L1. Actually, just matching L1 is enough. So an empty list, we just do return AC. As we go head tail, and we do head times find occurrences in list 2 of the head. We actually do the accumulation. Is it plus? I think it's plus, isn't it? Yeah. Plus, and then, so accumulation plus the head times this, plus similarity of tail, L2. Oh, and this goes in there, yeah. Like so. And then in that part2 equals similarity by giving it L1, L2, 1 in, and then part2. Okay, what's going on? Find occurrences. Unused ref. Oh yeah, because it doesn't need to. 32, is that 32? Ooh, 31. Oh, because we're doing accumulation, I don't need 1 here, because that was the multiplication thing. Great. Oh, actually, I can just, there we go. There it is. Let's just check that you're correct. That was, I copied an extra space, so let's just get rid of that. Cool. We're done. That's it. That did take a little while, but it is because I'm coming into this like so raw. Like I have no idea how to use this language, like at all. Like one thing I don't like, this here. I hate this here. This I'm pretty sure you can get types such that L1 and L2 are the exact same length. So are they called conditional types? I was listening to a podcast about it from Signals and Threads, Chain Street, because they use this language a lot. There's definitely ways of doing it, but yeah, this is super cool. I'll go share it on Reddit. I'm quite, yeah, no, I just think it's really fun. Jesus, this language, having a lot of fun, and yeah, let's just commit this, or maybe I don't want to commit underscore builds. Do I not want to underscore builds? Underscore builds. Okay, so we have this. Oh, the inputs as well. Not you. Okay, this. That's probably fine. This, and this. Okay, cool. Day 1. Ocaml. Okay, very cool. Thank you so much for watching, guys, and I'll catch you in the next one.